Hey everyone, welcome! Today, we're going to crack the code on something that's, well, it's basically a universal map for numbers. We're talking about the coordinate plane, and trust me, by the end of this, you'll be navigating it like an absolute pro. So, let's just dive right in.
I mean, have you ever really thought about it? How does your character in a video game know exactly where to move? Or how does your GPS pinpoint your location right down to the exact street corner? What's the secret sauce they all share? It's a common language, a language for location.
And that secret is the coordinate plane. You know, it sounds complicated, but it's a surprisingly simple system. All it is two number lines, one going side to side and one going up and down. And where they cross, they create this perfect grid. This grid, this is the map we're going to be exploring.
Okay, so think about it. Any good map needs some main roads, right? You know, the big highways that everything else is kind of built around. Well, on our coordinate plane, we've got two of them.
All right, check this out. This is our foundation. That horizontal line, the one that goes left and right, we call that the x-axis. Just think of it like the main street that runs east and west. And that vertical line, the one going up and down, that's our y-axis, our main north-south avenue. These two lines together, they create the entire grid.
Okay, so we've got our main roads. Awesome. But now, how do we describe a specific spot? You know, like a particular house or a cool landmark on the map. For that, we're going to need an address system.
Well, in math, these addresses have a name, ordered pairs, and they always look just like this, a number for x and a number for y, inside parentheses. The first number, the x, tells you how far to move sideways along that horizontal x-axis. The second number, the y, tells you how far to move up or down along that vertical y-axis. And get this, this is literally how a computer tells a video game character exactly where to stand on your screen.
Okay, this is my favorite part. To make this super easy to remember, there's this simple little rule. Always think run, then jump. You always run sideways along the x-axis first, and then you jump up or down along the y-axis. It's as simple as that.
All right, let's actually try this out with the address 3, 2. So, using our rule, first we run. We go 3 units over to the right along the x-axis. Then, from that spot, we jump 2 units straight up. And boom! Just like that, we've pinpointed our exact spot. It really shows you how perfectly precise this system is.
You know, every map has that one central point, right? That little "you are here" sticker that everything else is measured from. Well, on our plane, that special point has a special name.
That spot is called the origin. This is the exact point where our two main roads, the x and y axes, cross each other. And its address? It's 0, 0. Why? Well, because you haven't run anywhere yet, and you haven't jumped anywhere yet. You're right at the start. It's the true center of our entire map.
So when these two axes cross, something really cool happens. They actually divide our entire map into 4 totally separate sections, or as I like to call them, neighborhoods.
These 4 neighborhoods are officially called quadrants, and here's the really clever part. Each quadrant has its own unique style of address, based on whether the x and y numbers are positive or negative. It's kind of like a built-in postal code system for our map.
And the pattern is super easy to follow. We just go on a little tour, counterclockwise. We start up in the top right, that's quadrant I, where both numbers are positive. Then we swing over to the top left for quadrant 2, where x is negative but y is positive. Then we drop down to the bottom left, quadrant 3, where both numbers are negative. And to finish it off, we go to the bottom right, quadrant IV, with a positive x and a negative y. And that's it. That's the entire layout of our map.
And there you have it, the axes, the addresses, the origin, and all the neighborhoods. You now have the key to this whole universal map. And look, this isn't just some abstract thing for math class, you know. This is the actual backbone of everything from video game animation and computer programming to architectural design and data science. So the real question is, now that you have the map, where are you going to go with it?